Hi, I'm Rita. I'm here to teach you Class 5, Semester 2. Maths. Maths. 3. The perimeter AD. 1. Basics of geometry. 1. Basics of geometry. In this chapter, we shall learn about some basics of geometry. Let us understand some geometrical terms first. A point. A point is the basic unit of geometry. It is an undefined concept. A mathematical point has a fixed location. It cannot be moved. The tip of the pin can be taken as a physical model of a point. Capital letters of the English alphabet are used to show different points represented by dots. A line. A line is a collection of points extended endlessly, indefinitely in both the directions along a straight path. When the word line is used, it means a straight line. A line is represented as a double arrow showing that it can be extended without limit in both the directions. Is the symbol for a line. Point X and point Y are 2 points on the line. We call it line XY and write it as XY or YX. There is no beginning or end of a line. That is, it has no end points. Teacher's tip: get the pupils to understand the basic terms of geometry before doing the lesson. This will help them to understand things better. A line segment. A line segment is a part of a line. It has 2 endpoints. The dot represents the points. Point A, point B, point C, point D, point E. Now take a scale and join any 2 points. The figure that you get is a line segment. The edge of the book can be considered as the physical picture of a line segment. The symbol for a line segment is. Line segments are named by putting a bar over the 2 end points. The line segment shown below is named as PQ. The length of the 2 points is limited. It cannot be increased or decreased. Trixie, which geometrical concept does each of these remind you? A ray. A ray is a part of line. It has one end point and goes on endlessly in one direction. It is represented by an arrowhead on one side and a point on the other. To name a ray, the end point is named first. The ray shown above can be read as AB. Each line contains an unlimited number of rays: A, C, D, E, B, AB, AE, AD, AC, CD, CE, CB, DE, EB. The beam of the light comes out of a bulb can be compared to rays. Relationship between points and lines. Let us take a point P. How many lines can be drawn through this point? We can draw an infinite number of lines passing through this point. Lines that contain the same point on them are known as concurrent lines. Collinear points. If 3 or more points lie on a straight line, the points are called collinear points. A, B and C are points on AC. Point B is between point A and C. A, B and C are collinear points. Non-collinear points. 3 points that do not lie on the same straight line are called the non-collinear points. A, B and C are non-collinear points. Only 3 lines can be drawn through any 3 non-collinear points. A plane. A plane is a flat surface that goes on endlessly or extended indefinitely in all directions. A plane is a collection of an infinite number of points. A plane contains an unlimited number of lines, line segments, and rays. Exercise. Draw the following. Name the figures shown below. Draw lines AB, CD, EF and GH so that they can concurrent at a point O. Name the different rays contained in the line given below. Draw a line segment PQ. Make a point T between P and Q. Draw a ray TR. An angle. When two rays have a common endpoint, they form an angle. Point O is a common endpoint of OA and OB. The figure we get in angle AOB. The common endpoint O is called the vertex of the angle. OA and OB are the arms, sides of the angle. The symbol for angle is, we see angles around us all the time. Naming an angle. An angle is named in different ways. We can name an angle by using 3 letters of the English alphabet. For example, angle ABC, angle PQR, angle XYZ, etc. When 3 letters are used to name an angle, the letter showing the vertex is written in the middle. We can also name an angle by writing the vertex only, like angle B, angle Q, angle Y, etc. An angle can also be named by assigning a numeral to the angle, like angle 1, angle 2, angle 3, etc. Interior and exterior of an angle. An angle has 2 parts, the interior part and the exterior part. The points lying inside the angle form the interior of the angle. The points lying outside the angle form the exterior of the angle. In the given figure, points P, R and Q are the interior of angle ABC, and points S, T, Q are in the exterior of the angle ABC. Name the angles given below. Name all the angles in the figures given below. Give 4 examples of angles you see in your surroundings. Write the name of the angle, vertex, and sides of each of the following angles. Classification of angles. Angles are classified on the basis of their measurement. 1. An angle whose measure is 90 degree is called a right angle. M. Angle ABC is equal to 90 degree. If the hand of the clock moves from 12 to 3, then it has moved through 3 angles of 30 degree, that is 90 degree. Here are some examples of right angles we see around us. Project. Make a right angle tester to find right angles for you. Cut out a circle. Fold it as shown above. Fold it once again as shown here. This is the right angle tester. Now make the list of the right angles you can find around you using the testers. Trixie, how many right angles can you find in the basketball court? Two. An acute angle. An angle whose measure is more than 0 but less than 90 degree is called an acute angle. 3. An obtuse angle. Angles that are more than 90 degree but less than 180 degree are called an obtuse angles. 4. A straight angle. An angle whose measure is 180 degree is called a straight angle. M. Angle XYZ is equal to 180 degree. If we have two right angles next to one another, they form a straight angle. Exercise. Name the following angles according to their measurements. Identify the following angles and name them. Trixie, here are some examples of angles that we see around us. Classify them. Measurement of angles. In the measurement of angles, the unit of measurement is called a degree. The symbol of degree is as in 30 degree, 45 degree, 60 degree, etc. The protractor, baseline, center point, Inner scale, outer scale. We can use a protractor to measure the angles. If you look at the protractor carefully, you will see that there are two sets of measurements written on it. These are called scales. There is an inner scale and an outer scale, both having 0 degree to 180 degree in different directions. One scale is marked clockwise and the other is marked anti-clockwise. To measure an angle, follow the steps given below. Step 1. Let angle AOB be the angle to measure. Place the center point of the protractor on the vertex O of the angle. Step 2. Adjust the protractor in such a way that the baseline coincides with the arm OB of the angle. Step 3. Check the scale where the baseline arm points to 0 degree. Step 4. Read the measure of the angle where the other arm crosses the scale. The measure of angle AOB is equal to 45 degree, or M angle AOB is equal to 45 degree. Exercise. Measure these angles using a protractor and write the values. Write the measures of the following angles in the figure. To construct an angle. Example 1. Construct angle ABC is equal to 50 degree. Step 1. Draw a ray YZ. Step 2. Place the center of the protractor on the end point Y of YZ. Point Y will be the vertex point. Step 3. Adjust the protractor such that the baseline is along XY. Step 4. Now measure carefully from 0 degree on the inner scale up to 50 degree. Step 5. Mark the point X at 50 degree. Step 6. Remove the protractor, join X and Y to get XY. The measure of angle XYZ is equal to 50 degree. Example 2. Construct an angle PQR is equal to 120 degree. Step 1. Draw a ray RQ. Step 2. Place the protractor carefully on RQ such that the center of the protractor lies on the point R, vertex point. Step 3. Adjust the protractor such that the baseline is along RQ. Step 4. Measure carefully from 0 degree on the inner scale. Step 5. Mark point P at 120 degree. Step 6. Remove the protractor and join P and Q to get PQ. M angle PQR is equal to 120 degree. Exercise. Use a protractor to draw angles of 45 degree, 65 degree, 85 degree, 90 degree, 110 degree and 155 degree. Can you draw an angle of 0 degree? lines. Two lines lying in the same plane are called coplanar lines. AB and PQ are coplanar lines. Parallel lines. Two or more coplanar lines that do not intersect are called parallel lines. Parallel lines are equidistant from each other. The symbol for parallel lines is. Some examples of parallel lines seen in our surroundings are given here. A railway track, banks of a canal, opposite sides of a book, opposite sides of a blackboard. Parallel lines, parallel line segments, parallel rays. Parallel lines are vertical, horizontal, or oblique slant. Vertical parallel lines, horizontal parallel lines, oblique slant parallel lines. Intersecting lines. Two or more lines that cross each other or intersect at some point are called intersecting lines. AB and CD are intersecting lines that intersect at only one common point, 0. Two lines can intersect at one and only one point. Perpendicular lines. Two lines that intersect or meet each other to form a right angle are called perpendicular lines. AB and CD intersect at point O to form four right angles. The perpendicular lines are shown by AB is perpendicular to CD. Exercise. Classify the following lines as coplanar, parallel, intersecting, or perpendicular. Which English letters have parallel lines, intersecting lines, or perpendicular lines? Give two examples for each. Triangles. A triangle is a closed figure formed by three line segments. This triangle ABC is formed by three line segments AB, BC, and CA. These line segments are called its sides. The points A, B, and C are called the vertices of the triangle. Is used for a triangle. The above figure is written as triangle ABC. The angles made by the sides of a triangle are called its angles. Here the angles of triangle ABC are angle ABC, angle BCA, and angle CAB. A triangle can be drawn only when the 3 points are in the same plane but not on the same line. Classification of triangles. Triangles are classified in two ways. 1. According to the sides. 2. According to the angles. According to the sides. 1. The equilateral triangle. If all the sides of the triangle are of equal length, it is called an equilateral triangle. Triangle PQR is an equilateral triangle because PQ is equal to QR is equal to RP. 2. The isosceles triangle. A triangle with two equal sides is called an isosceles triangle. In the adjoining figure, triangle ABC is an isosceles triangle because two of the sides are equal. AB is equal to BC. 3. The scalene triangle. A triangle with all unequal sides is called a scalene triangle. In the adjoining figure, triangle MNO is a scalene triangle because NN is not equal to NO is not equal to OM. According to angles. 1. The acute angle triangle. A triangle having all the three angles acute is called an acute angled triangle. The triangle XYZ is an acute angled triangle because angle X, angle Y and angle Z are acute. 2. The obtuse angle triangle. A triangle with one obtuse angle is called an obtuse angled triangle. Triangle ABC is obtuse angled triangle because angle A and angle C are acute, but angle B is an obtuse angle. Therefore, angle ABC is an obtuse angled triangle. 3. The right angled triangle. A triangle with a right angle is called a right triangle or a right angled triangle. In the adjoining figure, angle P and angle R are acute, but angle Q is a right angle. So, triangle PQR is called a right angled triangle. It is also called a right triangle. Exercise. Classify the following triangles as equilateral, isosceles or scalene. Classify the following triangles into acute, obtuse or right-angled triangles. Quadrilaterals. A quadrilateral is a closed figure made of 4 line segments. Look at the figure on the right. It can be named as quadrilateral ABCD or BCDA or CDAB or DABC. This quadrilateral has 4 sides AB, BC, CD and DA. This quadrilateral has 4 vertices A, B, C, D. This quadrilateral has 4 angles: angle DADC, angle DDCB, angle DCBA and angle DBAD. The sum of the 4 angles of a quadrilateral is 360 degrees. A quadrilateral has 2 diagonals, PR and QS, as the diagonals of the quadrilateral PQRS. Types of quadrilaterals. A square is a quadrilateral whose 4 sides are equal in length. Here, ABCD is a square where AB is equal to BC, is equal to CD, is equal to DA, and angle A is equal to angle B, is equal to angle C, is equal to angle D, is equal to angle 90 degree. A rectangle is a quadrilateral in which opposite sides are parallel and equal and each of the 4 angles is 90 degrees. Here, PQRS is a rectangle where PQ is parallel to RS, PS is parallel to QR, PQ is equal to SR and PS is equal to QR, and angle P is equal to angle Q is equal to angle R is equal to angle S is equal to 90 degree. A parallelogram is a quadrilateral in which opposite sides are parallel and equal, and the opposite angles are also equal. Here, UVWX is a parallelogram in which UV is parallel to WX, UX is parallel to VW, UV is equal to XW, UX is equal to VW, angle U is equal to angle W, and angle X is equal to angle V. A parallelogram whose four sides are equal is called a rhombus. Here, MNOP is a rhombus in which MN is equal to NO is equal to OP is equal to PM. A trapezium is a quadrilateral whose one pair of opposite sides are parallel. Here, DEFG is a trapezium in which DE is parallel to FG. Exercise. Complete this table. What is the difference between a rhombus and a parallelogram? Fill in the blanks.